When we dream of exploring the solar system, we almost always look toward Mars. We send fleets of robotic explorers to comb through its red dust. But to get there, we willingly sail right past a world that sits much closer to home. This comparison shows Earth and our nearest planetary neighbor, Venus. At a glance, they are cosmic twins. They share the same mass, the same core materials, and almost identical diameters. Despite those similarities, stepping onto the surface of this sister world results in instantaneous, violent death. To understand why, we have to look beneath those glowing clouds and examine the specific, escalating environmental traps that make Venus the ultimate killing floor. Studying this extreme environment is vital because this hostility isn't happening in some far-off star system. It exists right next door to our own paradise. The danger begins the moment you hit the upper atmosphere. These thick yellow clouds are not made of water vapor. They are highly concentrated layers of sulfuric acid, capable of dissolving solid metal. High in the sky, these clouds produce a relentless acid rain. But as droplets fall toward the surface, they hit a wall of absolute heat. The temperature evaporates them in midair, turning them back into corrosive gas before they can ever touch the ground. If you survive the descent, you would find the air at the surface behaves strangely. It is so heavily packed with carbon dioxide that it acts more like a dense fluid than a breathable gas. This shows how that density translates to physical weight. On the left, a gauge dropping 1 vertical kilometer deep into Earth's ocean. On the right, a gauge sitting on the dry surface of Venus. The mechanical pressure crushing your body is exactly the same. The atmosphere acts as a dual-threat executioner, simultaneously dissolving and compressing anything that enters it. Then there is the heat. The surface temperature averages 465 degrees Celsius. That is hot enough to liquefy solid lead. This is Mercury, the planet closest to the Sun. By all logic of distance, Mercury should be the hottest object in our neighborhood. Yet Venus, sitting twice as far back in the dark, burns significantly hotter. Venus is trapped in a runaway greenhouse effect. Solar rays turn into heat at the surface, but cannot escape the inner cloud layer. Furthermore, its motion is counterintuitive. It takes 243 Earth days to complete one rotation, yet orbits the Sun in 225 days. A single day outlasts its entire year. The rotation itself is also unique. While Earth and nearly every other planet in our system spin counterclockwise, Venus spins backward. If you could stand on the surface, the Sun would rise in the west and set in the east. Between the lead-melting heat and the backward rotation, Venus follows a physical timeline that differs from every other inner planet in the solar system. This is a museum model of the Soviet Venera 13 lander. To survive the surface, engineers essentially had to build a titanium-armored safe. In 1982, they sent this machine directly into the furnace. The mission team estimated the machine might last 30 minutes before the environment breached its hull. Miraculously, Venera 13 held out for 127 minutes. For over 2 hours, its internal cooling fought a losing battle against 465-degree heat, while its joints creaked under 92 atmospheres of pressure. Before its systems finally melted, the lander successfully transmitted the first and only color photographs ever captured from the Venusian surface. That 127-minute window of survival remains our only direct visual proof of the most hostile terrain in our solar system. Evidence suggests Venus started its life as a world virtually identical to this before it became a toxic hellscape. Climate models indicate that for billions of years, Venus harbored liquid oceans and a stable, habitable environment. It was a perfectly viable twin to Earth. The tipping point arrived as the Sun naturally grew hotter over cosmic time. As Venus warmed, its oceans began to evaporate, releasing water vapor, a powerful greenhouse gas, into the atmosphere. This triggered a feedback loop that could not be stopped. The oceans boiled away, and the extreme heat began baking carbon dioxide straight out of the planetary rocks, saturating the air with gas. Venus serves as a record of what can happen to a stable environment. It shows that the only thing separating Earth's paradise from a runaway greenhouse hell is a delicate balance of climate and sheer luck.